All right, today for our notes, we're going to be talking about pure substances and mixtures. So next Monday and Tuesday, we're going to keep talking about physical and chemical changes. But since we already talked about chemical and physical properties, there's really not anything that we need to take notes on before we do class next week. So I'm just going to give you the notes for Wednesday, Thursday, and Friday. And so that's going to be pure substances and mixtures. Now, don't forget, we're going to be doing Cornell notes. So if you will draw a line down the left side of your paper, leave a couple inches on the left-hand side for questions that you can write in the question parking lot, or just, make sure you remember to ask us about it. And then on the right-hand side, you take your notes. The topic is pure substances and mixtures. That can go at the top. And you don't have to have an essential question, even though this paper says it on there, but I just want you to see the overall look of how your notes should be. All right, so there's a lot of definitions today and not so many examples. So hopefully when you come to class, you'll have a good idea of what the definition of all these words are, and then you'll be able to understand what we're doing in class. So the two definitions that we really need to start out with are pure substance and mixture, since that's what we're talking about. So a pure substance is matter that has the same composition all the way through it. So it might contain an element or a compound, but no matter what part of it that you take, it's going to have the same thing. So if you have a wooden table and it's only made of wood, then that would be a pure substance, because no matter what part of the table you look at, it's going to be the same kind of wood. Okay? If you had a table that was made of 3 or 4 different kinds of materials, that would not be a pure substance, because it's combined and made of a bunch of different things. Now, a mixture is at least 2 compounds that have been combined, and it can be homogeneous or heterogeneous. So we're going to talk about those words in just a second. But a mixture, an example of a mixture would be like a salad, where you have lettuce and then maybe cheese and croutons and tomatoes and carrots and dressing, and you put it all together in one salad. Now, we have these 2 words that were in our other definition, homogeneous and heterogeneous. So basically, these are really simple to understand. Homogeneous means the same throughout. Homo means same. You can probably think of a lot of words that start with homo, and when you think about what those words mean, it's going to have something to do with the same elements or the same people or the same objects, okay? And heterogeneous means different throughout. So this is going to be a mixture with different parts, just like our salad that I was just talking about, okay? So hetero means different. All right, so there are 2 main types of pure substances. One of them is elements. Elements are on the periodic table, and the periodic table has them represented like what's up here in the top right-hand corner. So an element is basically just the simplest form of a chemical that stays a chemical. So if we have the element hydrogen, we can't make hydrogen any smaller than 1 atom of that element. If we take apart an atom, then it might not have the same properties as hydrogen has. So then if it doesn't have the same properties, it really isn't the same thing as hydrogen, okay? So an element is just one type of chemical by itself, okay? The smallest part of the chemical. Now, an element obviously is always homogeneous, because if you have only oxygen in the room, then obviously any part of the air that you take will be oxygen, okay? If you have only calcium, if you have a calcium pill that you're taking and that's all that's in there is calcium, then of course it's homogeneous, because any part of that calcium pill is going to be calcium. So there's nothing else going on. Now, a compound is when you have two or more elements that are chemically combined. And when we say chemically combined, we mean that it really takes a lot to separate them. You can't just separate them like you would taking the raisins out of Raisin Bran, right? That's pretty easy. But a chemical that's combined takes a long and harder process to separate. All right, now compounds are always homogeneous as well, or homogeneous, you can say it either way. So the reason we know that compounds are always homogeneous is because if you think about water as a compound, it's got hydrogen and oxygen that are combined together, so it's two different elements combined. But yet, if you have a glass of water, it doesn't matter whether you look at the first drop of water or the last drop, it's still H2O. So it's homogeneous because it's the same throughout the entire glass of water. It's not going to randomly be something different in the middle. Okay? Now, there are three types of mixtures that we're going to talk about. So the first type really are two types, and they're very similar, which is why I put them together. So there are two types. One's called suspensions, and the other one's called colloids. And both of them are mixed somewhat evenly, all right? I want you to think about like a milkshake or a smoothie. So, you know, most of the time a milkshake is mixed pretty well, but every now and then you might taste more chocolate than normal, or maybe you get a taste of ice cream but not strawberry or whatever you put in there, okay? So suspensions and colloids are heterogeneous, and that means that they're different throughout. So if you have a smoothie, let's say you get a strawberry banana smoothie, you could take one taste of it and it would be more strawberry, and you could take another taste and it would be more banana, right? It's not going to be the exact same all the way throughout the smoothie. So that's why we call it heterogeneous, because it can be different depending on what part of the mixture you take out. Now, the difference between suspensions and colloids is if the particles can settle over time, it's a suspension. So if you think about orange juice, you have to shake it before you drink it because the particles will settle to the bottom and it won't be mixed evenly anymore. So you shake it up right before you pour it. That way it'll be mixed up. So if that happens, if the particles can settle to the bottom and be separate from the rest of it, then it's a suspension, okay? Because the particles are suspended in the rest of the mixture. Now, if the particles are too small to settle to the bottom, like they don't weigh enough or they're not dense enough to settle to the bottom, then it's a colloid. So your milkshakes and things like that sometimes will be a colloid because you can leave it sitting on the counter and when you go back, it's still pretty mixed. Nothing settled to the bottom, okay? So that would be suspensions and colloids. The last type of mixture, and this is our last slide, is called a solution. Now, solutions are very well mixed, and they should be uniform throughout. So that means they're homogeneous. So think about sweet tea or Kool-Aid or even things like Coke, Sprite. All right, those are solutions because they are mixed very well, even though you've put several things together, right? If you make sweet tea, you've put water, and then you've added the liquid from the tea bags, and then you've maybe added sugar, but once you mix it all together, it's even, right? Nothing settles to the bottom if you've mixed it the right way. You're not going to make a glass of tea and you go to the restroom and you come back and it's water with tea at the bottom, right? Once you make the tea, it's tea. It's not going to settle over time. So it's homogeneous, okay? Because every little part is going to be the same, all right? And a solution cannot be separated by a filter. So if you think about a milkshake, if you put a milkshake into a coffee filter, there would be some liquid that came through, but then all the big stuff would stay on top of the filter, right? Well, you can't do that to a solution. If you pour it into a filter, all of it's going to come through the filter. There's not going to be anything on top of the filter. So a solution a lot of times might be thinner than a suspension or a colloid because all of it will go through the coffee filter or whatever you're using. And like we already said, you can leave a solution sitting there over time and it's not going to, nothing's going to settle out of it. You're not going to have to mix it up or shake it up. It's going to stay like that permanently, okay? So unless you do something to reverse it. So you might be asking yourself, if solutions are homogeneous, why are they mixtures instead of pure substances? But the best answer for that is that a pure substance is generally chemically combined, okay? Which means that the combination happened between elements and compounds and it can't really be easily undone, all right? And even though a solution can't be filtered out, it was put together physically, not chemically, all right? In order to make Kool-Aid, somebody has to pour the powder into the water and add the sugar and mix it all up. They actually have to do that. It's not just going to happen on its own. Whereas for water, H2O, people don't have to come along and say, okay, we need more water, so I'm going to add the hydrogen and the oxygen together, and I'm going to make some water for the whole world. Nobody has to do that because it occurs naturally as a compound. So that would be the difference of why solutions are classified as mixtures and not pure substances. So hopefully this made sense to you. If you need to go back and get any definitions, feel free to rewind and pause and listen. And make sure you have these in class on Monday.